Imagine you are uncertain about a medical condition and are seeking a quick way to a quick diagnosis. Going to the doctor can result in a long wait for just a simple yes, no, or maybe. In critical times, a more accurate and a more faster method that can provide a precise diagnosis is very much needed. Solving this challenge requires the application of image analysis, a method that involves examining an image to find key details within an image. By analyzing it, we can identify significant patterns, features, and elements that can conclude and make an accurate diagnosis. However, with image analysis, we need to use a certain type of model that will allow us to classify which disease that person may have and to accurately classify it. This model is known as a convolutional neural network or a CNN. So why exactly do we use CNNs and not any other model? Well, when we are faced with the challenge of analyzing a high resolution image, which are packed with a ton of pixels, the other type of model, an ANN, an artificial neural network, will take a lot of time processing it since it goes through every single pixel. This allows for CNN models to be more practical and to be more efficient when it comes to dealing with high resolution images, since they only look for key features. A convolutional neural network, or CNN, is a special type of branch of machine learning which is highly effective for image analysis and is particularly better at processing high resolution images quickly. CNN models are very accurate, but the accuracy of a CNN model depends on the amount of data that we, the user, gives it so that the model can train on. The amount of data will make it more accurate, but there's another factor which also makes it more accurate, and that's the quality of the data. If we give the model a data set of poor quality data, it'll do a lot worse than if we gave it a high quality data set. This code segment enables the model to categorize X-ray images into different classes, effectively determining the classification for each image. This piece of code acts as the final step for our model and is the output layer in a CNN, and it will finally show the classified output and it'll present the user with what they want. While convolutional neural networks offer a wide array of applications that are highly effective in certain tasks, not every model is perfect, and each model has a limitation. A significant challenge with CNN models is that they require a ton of images in a big, large data set for them to function correctly and for the user to get accurate results. Also, the learning process for these models can take up a lot of time and need a long period for the network to be fully trained and for it to find patterns. Convolutional neural networks excel in image analysis, but there are better choices for object detection and images with a low amount of pixels. The model's numerous layers require a significant amount of time to thoroughly learn and adapt to all the tasks that we're asking it to do. And for using the full potential of CNNs, we need a computer with a powerful GPU to make sure the model operates efficiently and effectively. Some of the roadblocks while I was coding this app was making sure that the model has a good accuracy rate and it's able to correctly classify each image that I give it. And another challenging part of the process was finding right images. An example is that when I was finding the COVID images, there weren't really a lot that were given out to the public, so I had to use generative AI, which is where I take one image of the COVID X-ray, and I would ask the generative AI to generate more images similar to this one, so that I can get a ton of images to use it to train my model. During the testing phase of the app, I did a ton of tests across different diseases out of the four: pneumonia, lung cancer, COVID, and normal. And the model was able to demonstrate 100% accuracy in diagnosing each condition. And the accuracy shows the model's efficiency and how it achieved through learning from a large data set that I provided it with.